Hello everyone, today we're going to look at standard deviation in the normal curve. Standard deviation is a measure of variance, which is how varied or spread out the data is. So if the data is really spread out, the standard deviation is going to be high, and if the data are all close together, then the standard deviation is going to be low or close to zero. So the equation for standard deviation is the following. So what we have here is the Greek letter sigma. It's lowercase. And it kind of looks like a whistle, is what I've always thought. And then x bar is the mean of the values being the x's. N is the number of values. And this Greek letter, which is capital sigma, means the sum. So you've seen these guys in the mean section. So again, what we're going to do here is add the squares of the differences of our values and the mean, divided by n, and then square root at the end. So we're starting with a average or a mean of the differences of our points, our values, and the mean. So how far from the mean are our values? But if we just had this, then we would get 0 every single time. So all the positives would cancel with all the negatives. So that's not very helpful. I don't want something that's always going to be 0. So what we do is we square our differences so that A, small differences are even smaller, larger differences are even larger, so we're exaggerating them, and everything's either 0 or positive, so things can't cancel out. And then to counteract the fact that we're squaring everything, we square root it at the end. So that's where this equation is coming from. What I do, which I think makes things a lot easier, is I use the following table. So my first column are going to be my x's or my values. The next column is going to be the difference in my values and the mean. And then the third column is going to be those guys squared. And what I'm going to do is I'm going to add up each column as I go along. And we'll see how this is going to make our calculation of the standard deviation a lot easier. So we'll do it with an example. So find the standard deviation of the following values: 36, 24, 24, 30, 39, 27. So I'm going to start my table. So here it is all filled out. I'm going to go step by step on how we did this. So again, the first thing we do is we plug in our x's. And then down here is going to be the sum. So I add up all my x's, and I get 180. So then what I have to do next is find x bar. So x bar is the 180 over 6, which is the number of values I have. So x bar, the mean, is 30. So for this column, I'm taking my x and subtracting 30. So 36 minus 30 is 6. 24 minus 30 is negative 6. And then I keep going. So I have all these numbers. Again, it's just the value minus the mean. And then again, down here, I'm going to add them up. And as I mentioned before, I should get 0 every time. And if I don't get 0, then I know I did something wrong. Either I found the mean incorrectly, or at least one of my subtractions was wrong. So you always want to make sure that you're getting 0 for this middle column. Once I've confirmed that it's correct, I do get 0, I'm then going to square these values. So 6 squared is 36. Negative 6 squared, also 36. Remember, when you're squaring a negative, it's still positive. Okay, so these guys are all, my third column is just my second column squared. And then again, I'm going to add them up. So once I've added them up, that becomes the numerator in my equation for the standard deviation. So I have the square root of the 198 divided by the n from before. So again, they're both getting divided by 6, which is n. Don't forget that if you're going to do this all at once in your calculator, you might need parentheses there. You're square rooting after you're taking division which is against order of operations. So if we do it out, we should be getting 5.745. Okay. So we're going to try another one, but make sure you actually did out the calculations and that you're getting the same thing. So let's try another one. Find their standard deviation of 5, 4, 3, 3, 6, 8, 2, negative 1, 0, 10. So again, I'm going to start with my table. And again, I'll talk about how I get all these values. So again, this column is just my x's, so my values. Here I'm adding them all together. So if I add them up, I get 40, which tells me that x bar is 40 divided by 10, which is 4. So for my second column, I'm going to take my x value and subtract 4. So 5 minus 4 is 1, 4 minus 4 is 0, minus 4, and keep going all the way down to minus 4. Again, if I add them all up, to know that I'm doing it correctly, I should get 0. Okay. Once I have my 0, I know that they're all correct. I square them. So 1 squared is 1, 0 squared is 0, negative 1 squared again is positive 1. Make sure you're getting rid of all the negatives. Everything in this column should be 0 or positive. So again, I keep doing that. I square them all, and then I add them up, and I get 104. And again, that 104 becomes the numerator inside the square root. I'm dividing by 10, which again is n. Right, I've got 10 values. Square root of 104 divided by 10 should be 3.225. So this standard deviation was smaller than the previous one, which means our values are closer together than the first set, which were more spread out. Okay, so that's how you find standard deviation. So try out some more of those, make sure you're getting the hang of it. Again, I really suggest using the table. You don't have to, but I always find it a lot easier to use the table. The second half of this lesson is on what's called the normal curve. So the normal curve looks like the following. So don't worry, you don't have to have it memorized. It'll be given to you on any tests. So when I look at this, if I look at the x values, the 0 is corresponding to the mean. So if I have some set of information that is considered normally distributed, it's going to follow this curve. So if I'm asking you to use the normal curve, then we will assume that it's normally distributed, but I'm not going to worry about what that actually means right now. So again, the 0 corresponds to x bar, and then the plus 1, plus 2, plus 3 to the right, the negative 1 minus negative 2, negative 3 to the left, are telling me how many standard deviations I'm adding to the mean. So the plus 1 means I'm taking the mean and adding 1 standard deviation. Plus 2 means I'm taking the mean and adding 2 standard deviations. Plus 3 means I'm adding 3 standard deviations. And then to the other side, it means I'm subtracting. Okay, so these numbers are just telling me how many standard deviations I'm subtracting. That's not looking very pretty. Let me try that again. Okay, so what I'm going to be doing in a problem is I'm going to give you the mean and the standard deviation, and then based on those numbers, we're going to fill out the x-axis. So if I have, for instance, x bar is 20 and sigma is 3, then 0 would be 20, 1 would be 23, 2 would be 26, 3 would be 29, and so forth. So I'm going to be adding sigma as I go to the right, and I'm going to be subtracting sigma as I go to the left. So negative 1 would be 17, negative 2 would be 14, negative 3 would be 11, and so on. Okay, so again, I'm going to give you x bar and sigma, and you just have to fill in the bottom part. And then what we're doing with this picture is anytime I want to find the percentage of values between so many numbers, so in our case between 20 and 26, what I'm going to do is I'm going to look from 20 to 26, and I'm going to add the percentages that are between those two. So I would say that 47.5% of my values lie between 20 and 26. Okay, so these problems really just involve adding and possibly a little bit of multiplication at the end, but it's mostly just adding. So let's try it out, an actual example. So suppose 250 students took a test and their scores were normally distributed with a mean 82 and standard deviation 6. Answer the following questions. So I have my standard normal curve off to the left, and then I've got 3 questions. What percentage of students scored greater than 76? What percent scored below 82? And how many scored between 70 and 80? So the first thing I have to do is plug in my values. So the mean is 82, standard deviation is 6. So that means at 0, I'm at 82. I'm going to put my numbers down so that I have more room. And then plus 1 means I'm going to add 1 standard deviation. So 82 plus 6 is 88. And then at the plus 2, I'm going to add another 6, so 94. Then I add another 6, and I've got 100. Going back to the left, I'm going to take 82 and subtract 6, which gives me a 76. I'm going to move that a little closer. 76. Subtract another 6, gives me 70, and then another 6 is 64. Okay? And then what I want to do is, to make sure that I did it correctly, is I want to look at the numbers in the questions and make sure those numbers are on my x-axis. So 76, yes, that's on there. 82, yes, that's on there. 70, it's on there. 88, it's on there. So if your numbers aren't matching the numbers in the question, go back and recheck it. Okay. So going back to the first question, what percentage of students scored greater than 76? So I'm going to look at my picture, find 76, which is my -1, and then I want the percentage of students who scored greater than 76, so that is numbers to the right. So I'm going to add up all the percentages that are to the right. So the 34 plus the 34 plus the 13.5 plus the 2.35 plus the 0.15. And if I do that, I should be getting 84%. Okay. Notice that if I add all of them up, I get 100%, which hopefully makes sense. Okay. So I'm going to switch colors. For B, what percentage scored below 82? So I go to my 82, and I want below it, so I'm going to go to numbers to the left. So I'm going to have the 34, the 13.5, the 2.3, the 0.15, all to the left of 82. And if I add those up, I should be getting 50%. So something that's really nice about the normal curve is that if you notice, it's symmetric, right? So the percentages on the left or match up with the percentages on the right. And because of that 50% where my mean is, it tells me that my mean is also my median. It's also the mode, but it's really nice that the mean is the median. It splits the data in half. So remember, that's what the median does. Okay, so again, I'll change colors. And this one says how many scored between 70 and 88. So between 70 and 88, that is those 3 sections, the 13.5, the 34, and the 34. So the first thing I want to do is find the percentage. If I add up the 3 percentages, I will get 81.5%. Doesn't want to do the decimal. 0.5. But the question is how many, not what percentage. So I'm going to take that percentage and go back to, I have 250 students. So what is 81.5% of 250? So it's a basic percent problem. If I do it out, I get 203.75, but you cannot have a decimal of a person. So I can't have 0.75 people. So in this question, if it's people, make sure you're rounding because you have to have an integer as an answer. If it was the number of pizzas, then I could have 3/4 of a pizza. Okay, but it's students, it's people, so I need to round to an integer so that my answer actually makes sense. So again, 203.75 rounds up to 204. Okay, so let's try another one. The heights of a certain group of adult males are normally distributed with a mean of 70 inches and a standard deviation of 4 inches. Answer the following questions. So again, the first thing we're going to do is plug in our numbers. So the mean is 70, and then the standard deviation is 4. So I'm going to be adding 4 as I go over. So I've got 70, 74, 78, 82, and then as I go to the left, I'm going to be subtracting 4. So 66, 62, and 58. Okay, so for my first question, I'll do it in blue. What percentage of men are taller than 74 inches? So I find 74, I want taller. I'm going to add them together, and if I do my 13.5 plus 2.35 plus 0.15, I get 16%. Okay, for the next one, obviously the inches sign is on the wrong spot, so it's not 6 inches and 2 something. So what percentage are shorter than 62 inches? So I go to my 62, I want shorter, so I'm going to go to the left. And I've only got the 2 there, 0.15 and 2.35. So that gives me 2.5%. And then for my last question, I'll go to yellow. What percentage are between 66 and 74? So 66 to 74. So that's the middle 2. 34 plus 34 gives me 68. So you're going to start seeing the same numbers over and over again. 50, 68, 16, 2.5, I think 47.5 might be another one. So there's only so many combinations you can have here. So hopefully these numbers will start looking familiar. But let's try one more. So 400 students weighed the same object, and the results were normally distributed with a mean of 100 milligrams and a standard deviation of 2.5 milligrams. So you know sometimes when you weigh something, you're going to get a slightly different answer than if you do it again or if someone else does it. So we have 400 students who all weighed the same object and got slightly different answers. But these are normally distributed, and we're going to answer the following questions. But again, my first step will always be to plug in the numbers. So my mean is 100, so that is my first one. I'm going to try to just write them sideways this time. So 100. Standard deviation of 2.5. So for my number 1, I'm going to have 102.5, if I can write it. For plus 2, I'm going to have 105. And plus 3, I'm going to add another 2.5. Doesn't want to do a decimal. 107.5. For negative 1, I'm going to subtract 2.5. So 90, whoops, that's kind of terrible. 97.5. Again, it does not want me to put a decimal. Negative 2, so subtracting another 2.5 gives me 95. And then subtracting another 2.5 gives me 92.5. Okay. So for my first question, again, I'll do it in blue. What percentage of students measured less than 95? So I go to my 95, I want less than, and if I add up those two, I should be getting 2.5%. for B, I'll do it in green. What percentage measured between 92.5 and 105? So 92.5 up to 100.5. So that's going to give me the 2.35, the 13.5, the 34, the 34, and the 13.5. Make sure you're not including the 0.15 all the way to the left, because that are numbers less than 92.5. Okay, so I've only got those 5 boxes in the middle, and if I add them all up, I should be getting 97.35. These decimals, it doesn't want me to do them. And last question, how many? So again, it's not a percentage question, it's actually how many measured more than 102.5. So I go to my 102.5, I want more, so again I add up all the percentages, and it's as a percent, 16%, so again there's that 16 again. And then the question is, what's 16% of 400? Again, that's the basic percent problem, and we should be getting 64. Okay, so make sure that you're answering the question. Is it a percentage or is it an actual number of whatever it is? Okay, and again, this happened to be an integer, but it is still students, so make sure, even if it doesn't come out exactly as an integer, that you do round. Okay, so read the book, try out some of the homework problems, and let me know if you have any questions. Thanks.